Professor Worgley's here. We've taken a look at how to make threads. One is extending the thread superclass. Two is implementing the runnable interface. Both define the run method. Okay, so no matter how you make a thread, you have to make the run method. The only difference is how you start the thread. But no matter what thread you create, you always have to call the start method. So these are two things that are very important for the final exam. You need to know the run method. You need to know the start method. You need to know why some of those methods are deprecated. Why is the stop method deprecated? That's very important to know. Now, what if I want to make a thread and I don't want to go through the hassle of creating my own class? I just want to get a thread up and running and do a simple count. You'll see here in my counter threads, they're just a basic for loop. Do I really need this class just to run a basic for loop? The answer is no. If you want to create a thread, you don't necessarily have to do it in your own custom class. So for example, if I scroll up to the top, you'll see I have the thread superclass. I have thread 3 and thread 4. So if I scroll down here, let's say this was supposed to be for thread 3. So let's say I go to thread 4. Let's say I just want to make a thread. I don't want to make my own class. I just want to get a thread up and going, nice and easy. I can do that here. So let's say I do thread 4. And let's say thread 4 instantiates the thread superclass. Now I need to write some code here. I need to define the run method. I can't do that with just the thread superclass. So I can't instantiate it like this. And then I can't say, okay, thread 4.run, is equal to this. I can't do anything like that. So I actually have to instantiate the runnable interface. How do I do that? I'll actually call new runnable here. And then this is where I put the run method. So the runnable object will override the run method. Run method is public void run. And once I have all of this implemented here, you'll see no errors. So here's that same run method. This is the same run method, let's say here. In this example, I have a for loop and I want to update some information. I don't need to create this whole class. I could do it simply by creating a thread and passing a runnable object to it that overrides the run method. Okay, so here I have a basic for loop. Okay, you'll see that here, and it basically will run to, what is this? Looks like 1,000,000. It'll run to 1,000,000. It prints it out to the console, and that's it. Now, this is just like creating counter runnable, and this is just like creating counter thread 2. You'll see eventually I have to call the start method. So here I have thread 4. If I run this and click start, it's not going to start automatically. I have to call the run method. So if I click start over here, nothing happens. So eventually I still need to call the start method. Now, this is the thread superclass, so I can call it directly. I can say thread 4.start. And now the run method will begin executing. Now what's cool about this is I have a thread here. It's a thread superclass, so it's a predefined class. And I'm basically overriding the run method. So if I click start, you'll see it prints out fine, which is exactly what this first one is doing. So you can think of the first one and the fourth one basically doing the same thing. The only difference is I don't have my little exit. So if I close this, let's say I click start here, and I close this, you'll see the first one stopped, but the fourth one will continue to run. So I may need a little if statement here, just like we had before, to exit the thread, but essentially they're the same. Okay, they're essentially the same. Now what's cool about this is runnable, remember, is a functional interface. So if I come back here, it's a functional interface. And what that means is, you'll see I have a warning here. It's saying, hey, this anonymous inner class can be turned into a Lambda expression. Notice this is an interface here. This is runnable. How can I instantiate an interface? Normally, interfaces cannot be instantiated. Normally, they're all abstract. And normally, you're going to implement it on a class. You're going to inherit it to a class. But not with a functional interface. With a functional interface, I can actually create an instance here. And I can actually turn this into a Lambda expression. So if I copy this, and I'm going to comment this out, and I paste it down below, and I'm going to clean up the code, And I'm going to click on this warning so you can see the before and after. It says use Lambda expression. This code here is the exact same as this code here. The only difference is here you'll see the parentheses for the run method, and then the arrow basically covers all this. Now I can use an arrow because remember with the functional interface, there's exactly one abstract method. So I don't need to provide the override annotation. I know there's exactly one abstract method, so I know what method I'm overriding. I don't need to tell the system what method I'm overriding because there's exactly one abstract method. So I can get rid of all of this. I don't need to type all of this, and it's a little bit confusing, to be honest. This is one thing on Java that a lot of developers do not like. First, I'm instantiating an interface. That's usually not allowed. And also, I'm overriding the run method inside this. What is this? This is an anonymous inner class. Okay, that just looks weird. It's a weird syntax. We did that on event listeners, and we did that other places throughout our experience here in 3330. And a lot of developers don't like this, but a Lambda is easy. I just put these parentheses here. That's the parentheses for the run method. And I'd use an arrow, which is overriding the run method. And I put the block of code. So Lambdas are frequently used, and most developers tend to use them. It's less code and it's cleaner. Okay, it's cleaner. Now I have the same for loop and I have the same start method. So it's the exact same lines of code. The only thing you may want is a way to exit out. So I can create another variable. Let's say, I don't have the class here, so I can't change that class. That's the bad thing about using the thread superclass is I can't create the stop variable. But I can create a variable here. Maybe I call it thread for stop in the controller. And when thread for stop is equal to true, then I'm going to return. And this is returning from the run method. So remember, I'm inside this run method here. So I'm returning the run method. Now I'm going to have an error here. It's going to say illegal start of type. Okay, it can't find this variable. So if I go up to the top, I can create this variable. Let's say it's a private Boolean. You'll see actually here exiting. I could have used that. And let's just say thread for stop is equal to false at the beginning. If I scroll back down, does that error go away? It does. If I were to create that as a local variable, it usually does not like local variables in lambdas. If you remember, we did that in the timeline stopwatch. They had a problem there. If I create it as a local variable, we can get rid of this private. Actually, it accepted it. Okay, it accepted. I remember with the timeline, it did not accept it. It did not like local variables. But if I put it back to a global variable, we'll want it as a global variable. That way I can access it here. So it doesn't really matter the order. I'll just put it at the bottom. I'll say thread 4 does not equal null. Then thread for stop is equal to true. That way we can exit that thread when the user closes the UI. So I don't have to go through the trouble of creating my own class. I use the thread superclass. I can override the run method, and I can get a thread up and running with just maybe 5-10 lines of code. I don't need to go through all that trouble creating my own class. So if I run this, let's make sure it works. So I have my first thread. The first thread and the fourth thread are now the same thing. So I can start this one up, start this one up. You'll see they're both executing concurrently, simultaneously. Start this one up, start this one up. All 4 threads are running at the same time. Okay, so start, 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 and start. I have a bunch of threads running now. They're all happening concurrently. No problems updating the UI, no problems outputting to the console. This is not updating the UI. This is outputting to the console. So I don't need to run that on the main thread.